So we're going to take a look at second part of 7.2. There are going to be some things, as I just mentioned, that you need to know from earlier, but I'll put them up on the board again, so they'll be in the video if you need them. Okay, the first thing we're going to do is we're going to learn how to take something, just to show you, that looks like that, and get rid of all the trig. That means when you're done, you're not going to see the word sine or inverse cosine. So we're going to turn it into purely an algebraic expression. So an algebraic expression means it might have letters in it, addition, subtraction, square roots, multiplication, division, but it can't have the trigonometry function. No sines, no cosines. We're going to get rid of them. Okay? And I'm going to show you how to do it. So the key is going to be to start with the inner function. Okay? And we're going to try to set up a diagram for it. Now, once you get better at this kind of stuff, you might not need to draw the diagram out, but I think for a lot of people, the diagram is just going to make it easy to see like what's opposite, what's adjacent. I think a lot of people get very confused if I skip that whole step. So I'm gonna do a diagram, and when I say inner trig function, just to kind of show you the next problem, I mean this. That's the trig function on the inside. Okay. So there'll be an outer one and then an inner trig function. Now, if the inner trig function is inverse trig, okay, and if it's got the little -1 kind of above the trig function, it helps to rewrite that with regular trig. Rewriting it with regular trig instead of inverse is what's going to enable you to set up a diagram. Now again, could you kind of skip that and draw the diagram without doing that? Yes, but I think it's more confusing. So we'll do each step. As we go through, I told you there were a couple things to keep in mind. The main thing you have to remember is the Pythagorean Theorem. So keep in mind the Pythagorean Theorem and SOHCAHTOA. So the fact that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent's opposite over adjacent. So if you've got SOHCAHTOA and the Pythagorean Theorem, that's all you need to do this first part. Okay, now let's try one. So let's go through one and see what we do. So it says to write an algebraic expression. So what they're saying there is get rid of everything that's trig. Sines, cosines, secants, get rid of them all. And we're going to turn it into just algebra. Okay, now just a reminder about this. Okay, inverse cosine. If I go to my calculator and I put it in degrees, and I do second inverse cosine of 0.5, I get the answer 60. Does anyone remember, what is that 60? 60 what? Degrees, yes. Anytime you do inverse trig, doesn't matter what you type in. Okay, if you type in some number and you hit enter, the number that you get on the screen is an angle. Whether it's degrees or radians depends on the mode of your calculator. But the important thing to remember is inverse trig always gives you an angle. That's why we use it. So for now, I'm going to forget about the sign on the outside. I'm going to come back to it. I'm just going to work with the inside trig function. Now, I don't know what it's going to equal. I know it's inverse trig. I know it's an angle. I don't know what the angle is because I don't have a number to plug in for it. All I have is a v. So I'm just going to say that it equals theta. Right? Theta is the generic variable we always use in trig to represent an angle. Okay. So theta used to represent unknown angle. That's what it's used for. All right, So basically, this whole thing I circled, I'm calling it theta. So when I'm done, the goal of this problem is to find the sine of theta. That's what we're doing. Where theta is inverse cosine of v. I'm just kind of shortening inverse cosine of v to one thing. Just shortening it up. Now, the step here is said to take the inner trig function and rewrite it using regular trig. So what I would like to do is get rid of that inverse cosine. Does anyone remember what trig function cancels out inverse cosine? Yeah?
Cosine.
Cosine, regular cosine. So the correct way to say it is take the cosine of what's on the left, just kind of squeeze it in. Take the cosine of what's on the right, regular cosine, inverse cosine cancel out. Now all you're left with on the left is a v by itself, and on the right, cosine theta. Now, this is what I'm going to use to make a diagram. So the step, now we want to set up a right triangle diagram. So draw a right triangle. Now, people that have done this or know how to do this kind of thing, they would probably skip all this drawing stuff. They would just jump right to the final answer. But I'll show you how to do the sketch, and then if you get better at it and you want to skip the sketch, you can skip it. Now, you have to put theta as one of the small angles. It doesn't matter which one. Put it wherever it makes you happy. Just don't put it as the 90. Now, there's one thing we know about theta. Looking at the equation up above, it says that the cosine of theta equals what? It equals v. Now, what's the definition for cosine? What divided by what? It's adjacent over hypotenuse. And we know that in our problem, the adjacent divided by the hypotenuse has to come out to what? What did they tell us? V. The cosine of our angle is v. Now, if you can write v as a fraction, that will automatically tell you what to label the adjacent and what to label the hypotenuse as. So how could you write v as a fraction? Yeah, just put it over 1. Now, you just figured out two sides in this diagram. The adjacent side is v, the hypotenuse is 1. Adjacent divided by hypotenuse, v divided by 1 is v. That's exactly what this equation says right here. So here's the picture. Here's the equation that we used to get the picture. Any questions on up to that part? But now we're ready to get the final answer using that picture. They want to know the sine, okay, of theta, the sine of the picture I just drew. What two sides does sine involve? It's what over what? Sam?
Opposite over hypotenuse.
Opposite over hypotenuse. Hypotenuse, that's fine. I have it. Do I have opposite? Oh, Help? Do I have the opposite? No. I'm missing it. But I do have 2 out of 3 of the sides. So how can I get the third side if I know 2 of them? Okay? Yeah, we're going to use Pythagorean Theorem. If you want to call the third side x for now, you can. We're going to cross that out in a second because we're going to know what x is. And we're not going to have a number for it, but we're going to have a formula for it that involves v and 1. So let's set up Pythagorean Theorem. X squared plus v squared. I mean, you can put 1 squared, but 1 squared is just 1. Okay, now, Isabel, I'm trying to solve for x. So what's the first thing I could do to get x squared by itself? What could I move to the other side?
V squared?
Yep. And how would you move a positive v squared to the other side?
You need to subtract V squared from both sides.
Yep. So that's the first step. So x squared is 1 minus v squared, but I want x. So how would I get x instead of x squared? Yeah? Take the square root of both sides. So there is your formula for x. So the opposite side is the square root of 1 minus v squared. Now we can answer whatever question they want to know because we know all three sides in the triangle. They want to know the sine of the picture we just drew. Sine is opposite over hypotenuse. So write that down and that's your answer. Opposite, square root of 1 minus v squared. And now normally I would put over the hypotenuse, but why don't I need to put over 1? Because when you divide something by 1, it never changes. So that is the answer. It's always a little weird going through it the first time, so we're going to do another one. But I'm going to show you that.
Is it correct to leave the square root?
Yes, it is. Yep. You can't cancel this square because of the subtraction. Right? Anytime there's addition or subtraction, that messes up canceling it out. Okay, so let's take a look at what's on the left. It's what I started with. Let's look at the formula on the right and see if they come out the same. So we have the sine of the inverse cosine. Inverse cosine, and I have to use x, I can't use v. And let's make sure we do this in radians. So that's the original problem. Now let's put in what we got. If these two formulas are the same, what should happen when I graph them?
You only see one line.
Yeah, it should be one right on top of the other. So let's go zoom 7. There's the one on the left. I don't know if you saw it, but I traced over it, the one on the right, and we got exactly the same thing. Okay. Another way you can check that your answers are the same, try plugging in different numbers. If you plug in 0.2 to the formula on the left, you get 0.9798. If you plug it in on the right, 0.9798. They will come out exactly the same, no matter what numbers you type in, because they are the exact same thing. One of them has trig, the other one doesn't. So that's the goal of what we're doing. Taking stuff that has trig, getting rid of the trig. Okay, not even going to ask if there's any questions. We're just going to try one more. This time I'm going to ask you a little bit more what to do. And just follow the same steps we just did. Regular trig on the outside, inverse trig on the inside. Let's try this one. So this time my regular trig function on the outside is tangent. The one on the inside is inverse sine. All right, so part of that I can ignore for now when I set up my first step. Okay. Anyone remind me, what do I do for my first step? There?
Solve what's on the inside.
All right, take what's on the inside. And you remember what we set it equal to?
Theta.
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 So take what's on the inside, set it equal to theta. That was our first step. Now, what was the second step?
Cancel out the inverse sine.
Yes, I want to get rid of the inverse sine because I'm getting ready to draw a picture. And how do I cancel out the inverse trig here? What function do I take on each side? Okay, take the sine. Take the sine of what's on the left. Take the sine of what's on the right. Now you have v equals sine theta. So now we can get ready to draw the diagram. Before I label any of the sides, what do I have to put in the diagram somewhere? Theta, doesn't matter where you put it. I usually just put it right there. Now, what do we know about the sine of theta? We know that sine is opposite over hypotenuse. So somehow I need to label this side and this side. But I already know what the answer should be. When I divide the opposite by the hypotenuse, I should get V as the answer. So what could I make the opposite? And what could I make the hypotenuse? Sam?
1 and V.
And which one do you want to be V?
Opposite.
All right. And that makes 1 the hypotenuse. Let's check it. Sine of theta. Opposite over hypotenuse. V divided by 1, according to my diagram. Yep, according to the formula up above, it should be V. That's exactly what it should be. Now we're ready to get the final answer, but that usually involves figuring out that side. They want to know the tangent. Okay. Tangent is which two sides? What overlap? It's opposite over adjacent. Opposite's good, I have it. Adjacent, I don't. So I'm missing it. You're pretty much always going to be missing it. How do I get the side that I'm missing, knowing the other two? Pythagorean Theorem is actually the same problem as last time. One of the legs is V, the hypotenuse is 1. We just did that right here. That leg is V, the hypotenuse is 1. So it's going to come out the same. Square root of 1 minus V squared. Now we've got every side labeled, so we can answer whatever question they want. They want tangent. Opposite over adjacent. So the opposite is V divided by adjacent. Square root of 1 minus V squared. And we've gotten rid of all the trig. So we have a formula here that is equivalent. But there's something wrong with this one. What's wrong with that one? This didn't happen in the last one. But something happened here that we don't like. Jake?
Square root's in the bottom.
Right, we got a square root in the bottom, so we fix it just the way you always do. Multiply top and bottom by the square root. 1 minus square root of 1 minus V squared. Square root of 1 minus V squared. In the top, there's not much you can do. V square root 1 minus V squared. But in the bottom, the square roots cancel. That's why we did it. So you're left with this. Okay, I'm not going to type that in, but if you put what we started with in Y1, you put this formula in Y2, they would be exactly the same. One has trig, one doesn't have any trig at all. Okay, I think there's 3 problems like that on the test. 3 of those to do. Now, remember, when you see this symbol, it's the same as this. So if you ever see the word arc sine, it's another way of writing sine to -1. If you don't like seeing the word arc sine, cross it out and rewrite it that way. But those 2 things mean the same thing. You can also see it for arc cosine and arc tangent. We usually write it with the -1. Okay? But that's another way of saying the same thing. That's how the calculator does it too. Okay. Any questions on that? All right. All right, let's try, we'll try 2 more of these type, and then we're going to do the last thing, which relies on some of that other stuff I showed you. Inverse sine of the tangent of 3 pi over 4. So they want us to figure this out without a calculator, which means it has to be a special problem. It can't come out to like random numbers. Something special must happen here. When you solve when you simplify an expression, you always use PEMDAS. Right? Start with your parentheses. So forget about inverse sine for now. see if we can figure out what number is on the inside. The tangent of 3 pi over 4. Now, for me, I always think of it a little bit better in degrees. Does anybody remember what pi over 4 is, if you change that to degrees? It's 45, but this is triple pi over 4. So what's 45 tripled?
135.
135. We haven't solved anything yet. All we've done is rewrite the problem if you like degrees better than radians. If you prefer radians, don't do this stuff. Now, just the way I don't know if it was Sam or someone just said it, it's 45 times 3. That means this is a multiple of 45. So we're going to draw this out, and we're going to make a 45, 45, 90 right triangle. If this is 90, and that's 180, where's 135? Closer to 90? Closer to 180? Or right in the middle? It's right in the middle. That's 135. And that's a 45, 45, 90 right triangle. How do I know that? Well, if I take 135 minus 90, I can see that this section I'm highlighting in bold is 45 degrees. Well, if this is 45 degrees, then that must be 45 degrees as well, because it's a quadrant, and it makes a 90. So that's 45, that's 45. Okay, so I'm going to take this triangle, just to make it easier so I have some more room, I'm going to put it over here, and I'm going to make it larger. So there's my 90, 45, and 45. Now, when we did this before, we used unit circle trick. This is my hypotenuse, but it's also my what in the circle? Like if you erase the sides of the triangle, what is that line from the center of the circle to the edge? Anyone remembers what? Yeah. Well, its length is going to be 1. That's what I was going to get at. And what's it called? The segment from the center of a circle to the edge. The radius. Yeah. So it's the radius of the circle. So, don't overthink it. The radius of the circle is the same as the hypotenuse of the triangle. And Jayden just said what we always used. We used a 1. Now, the other two sides just have to kind of come from memory. Does anyone remember what these two sides are in a 45, 45, 90 right triangle? They involve square roots. And they're the same because that's an isosceles triangle. Whatever this one is, this one at the bottom is the same. I'll give you a hint. For the 30, 60, 90, the sides are 1/2 and root 3 over 2. Those are not the numbers we're using here. What's that?
Thanks.
So it's the other number that we learned. Yep. You're very close. I think you just said something, one thing you didn't need to say.
Is it like 0.707, that weird number?
Well, you're right as a decimal, but the way she said it is very
The other
close.
way.
Yeah?
Square root of 2.
Square root of 2 over 2. Yes. Now that we have a diagram set up, this is kind of like the last problem. You can figure out whatever you want to know because all your sides are labeled and none of them are letters. They're all numbers. They want the tangent. What's tangent again? opposite over adjacent. And what do you get here if you take that angle and do the opposite divided by, and now I should be careful when I label these, because you went, this side is left, this side is up. So this bottom number should really have a what with it? It's a negative. Just to take into account the direction. Okay? If you were down here, it would be negative, negative. If you were over here, positive, positive. So you should put the sign with it. So now, what's opposite divided by adjacent? Negative 1. So I told you in this problem it has to come out to a nice answer if we're going to be doing it without a calculator. It can't come out to something like 0.6473, some random number. It's got to come out to something special. And this came out to negative 1. So we just figured out that part. The tangent of 3 pi over 4 is negative 1. Now we just have to figure out the last part. The inverse sine of negative 1. Well, what did I say earlier? Anytime you do inverse trig and hit enter, your answer always represents what? It always represents an angle. So what, if you want to think of this last part a little differently, you're thinking it like this. The sine of what angle would come out to negative 1? That's what we're trying to figure out. If you take the sine of what, you'll get negative 1 as an answer. So the easiest way for me to think about that is think of the picture of sine. It looks like this. This is 1. This is negative 1. How many times does that picture hit negative 1? Just once. Right there. If you can figure out what that coordinate is, that's the answer to the problem. So look at the cycle. It hits negative 1. How far through the cycle? Like halfway through the cycle? 3/4. It's 3/4 of the way through the cycle. So in degrees, it's 360. In radians, it's 2 pi. So let's do it in degrees. What's 3/4 of 360? 270. If you did it in radians, it's 3 pi over 2. Okay. Either answer is correct. 270 degrees or 3 pi over 2. Okay. Don't get super worried about this kind. The other kind that we did for the first two, those are very important. You're going to have 3 of those on the test. Something like that you might see as a bonus question. Because it's a little tricky, but if you remember the unit circle, these root 2 over 2s, that's what makes it doable. Okay. Right. Let's try one more of the first type. Regular trig on the outside, inverse trig on the inside. Now, this one is exactly like this one. The only difference is the one we're doing now, it's all numbers. You're not going to have any letters in the problem at all. So if we set this one up kind of like the first one we did, what's the first thing I have to do? Set what equal to theta, yes.
The sine -1, or sorry, our sine of 1/2.
Yep, so the inverse sine of 1/2 equals theta, step 1. What's step 2? Do what, Jake? So take the sine of both sides, and when I do that, what's going to be alone on the left? 1/2 is going to be by itself. What's going to be on the right? Sine theta. Now, these two numbers are telling you directly the length of two sides in this diagram. put your theta somewhere in the diagram. The top number is which side? It's the opposite. The bottom number? Hypotenuse. 1, 2. So it's just like what we did before, except now we do Pythagorean Theorem. There's no letters. Okay? So now Pythagorean Theorem to get the last side. 1 squared plus x squared equals 2 squared. 1 squared gives me 1. 2 squared gives me 4. Greta, if I get x squared by itself?
Then it would be x squared equals 3.
And then x would be?
Square root of 3.
Square root of 3. So now I have all the sides. Let's go back up and see what they want. Cosine. They want the cosine of the picture I just drew. Michael, what's the definition for cosine? Like that, yeah. Yeah. Adjacent over hypotenuse. Adjacent over hypotenuse. Square root of 3 over 2. And that's the answer. Okay, so any question on it? Okay, that's the type you want to focus on. Regular on the outside, inverse on the inside. Alright, okay. So, last thing we're going to look at is solving trig equations. Okay, so remember, trig equations are periodic. What that means is if you can find one solution, there's infinite. If you can find one, that one repeats forever and ever. Now, in a trig equation, how often does a solution repeat? Every what? Every cycle. Whatever the cycle is. So that's part of doing this. You have to know how to find the cycle. And it's two formulas. 2 pi over b and pi over b. So solution repeats every cycle. Now, when we're checking our answer on the calculator, remember, we only have buttons for sine, cosine, and tangent. How do you type in something like cotangent on the calculator? There is no COT button. Tim?
Is it 1 over tangent?
It's 1 over tangent. So anytime you've got to type in secant, cosecant, or cotangent, you've got to take one of the other trig functions you do have a button for and flip it. So we'll look at 2 examples. Yes?
Can you tell us what we'd have to type in for certain ones?
We're going to do one where you do have to type it in as 1 over because you don't have a button for it. That'll be the last one. Yeah, we'll do one. Alright, so let's solve this sine of x equals 0.6. Usually the first answer to get is quick. All you have to do here is get x by itself. So to get x by itself, you've got to cancel the sine function. How do you cancel out the sine function? Yeah? So division, addition, subtraction, multiplication. Any arithmetic you want to do only applies to letters and numbers. You can't do arithmetic with a function, with a word. Yeah? Right. Only way to get rid of a function is to use another function. And Jake just said it, inverse sine. So take the inverse sine of what's on the left. Take the inverse sine of what's on the right. Inverse, regular, gone. Now you've got x by itself. And we're about to get our first answer. So let's just see what it is. And I'm in radians. If you do it in degrees, you're going to get something different. Inverse sine of 0.6. 0.644. Now, the directions didn't say to just find a single answer. They said to find every single possible answer. So that 0.644 is going to repeat how often? Every y. Every cycle. So what we have to do is put something like this. When you see the words all, you should put plus. Actually, let me write it like this. You find one answer just the way we did, and then you have to put plus the period times n. What that means is you can add any multiple of the period to 0.644, and you'll get an answer in another cycle. If you add two multiples of the period, you get an answer 2 cycles later. If you subtract 3 multiples of the period, you get the answer that's 3 cycles before this one. Okay? So we just have to find the period. For sine, what's the formula to find the period of a sine function? You have a choice of 2 pi over b and pi over b. If you wanted to do degrees, you would say 360 over b and 180 over b. But we're doing radians. Yep? It's 2 pi over b. In this case, b is just 1. There's no number in front of the x other than 1. So 2 pi over 1 is 2 pi. So that is how you write that solution. It's 0.644 plus any multiple of the period. That's what this means. So n is an integer. It's basically, n is how many cycles away do you want? You want the answer for the 10th cycle? Then plug in 10. And that'll give you the answer 10 cycles later. Okay? Because it repeats forever. All right, so next thing we have to do is, there's a second answer. If you didn't know there was a second answer, graph it. Graphing is what would tell you there's a second answer. Put what's on the left in y1, put what's on the right in y2. And when you're looking for where two graphs are equal, we're looking for where they do what? We're looking for where they intersect. Now, I don't want to see them intersecting forever. All I want to see is how many times do they cross in one cycle. So the easiest way to view one cycle is to start at 0 and go the length of your cycle, 2 pi. If you wanted to go like 2 pi to 6 pi, or I'm sorry, 4 pi to 6 pi, that would work. Because 4 pi to 6 pi is a difference of 2 pi. You could do 20 pi to 22 pi. But why? You have to set a window that's 2 pi units wide. 0 to 2 pi is the easiest way to do it. Okay, let's hit graph and see what we got. So, if you didn't know that there were two answers before, now you would. We just found this one. Let's do second calc intersect. Just to double check that we did it right. If I do intersect, I get 0.644. That's exactly what I got. So there's the first answer, and remember that answer repeats every 2 pi units forever. Now the question is this one. I can show you what it should be. If we go over here, it should be about 2.5. But how do we get that? Look at the original problem. It says sine of x equals, what kind of number is 0.6? And by kind of number, I mean positive or negative?
Positive.
It's positive. So if I go, let's bring up our chart. We're looking for where the sign is positive. Okay. You just got an answer there. How do I know that? What was the answer we got? Point what? 0.644. Well, this quadrant ends at 90. Or if you want to think of it in radians, it's pi over 2. This quadrant ends at 1.57 and it starts at 0. 0.6 is right in the middle of 0 and 1.57. So you just got an answer here. The other place that sine is positive is right here. Quadrant 2. So all we have to do is look up how do you get an answer in quadrant 2. And that's right there. It's 180 minus your reference angle. What's your reference angle? The reference angle is the answer from quadrant 1. So all you have to do is take the answer you just got and subtract it from 180 if you were doing degrees. We're doing radians. What is that 180 going to be replaced with? Pi. So we know sine is positive in quadrant 2. There's the formula for quadrant 2. Do pi minus the answer you just got. And let's see if you get 2.498. So I need to go back to my answer for a second. 0.644. Let's do pi minus 0.644. See what happens. Pi minus 0.644. 2.497. And turn this back on. 2.498. It's the same thing. It's just rounding. And actually, if I round that properly, it's 2.498. And that is your other answer. Now, just like the one above it, that answer is going to repeat at exactly the same frequency as the other one. It's going to repeat every 2 pi units. Forward and backward. Okay, so first answer, pretty easy to get. All you have to do is inverse trig on each side, and you're done with that one. The second answer, you have to look at the chart right here. Decide where the other quadrant is you need, and then look up the formula for that quadrant. The way you're going to know if you should even be looking for a second answer is you're going to graph it. If you graph it and you see 2 graphs cross twice, then yes, you need to write a second answer. If you graph it and they only cross once, you don't need to worry about the second answer. You wouldn't need to worry about this chart at all. All right, so let's try this one. Cotangent x equals 2.5. Now, what's kind of a pain about cotangent? Yeah? It's 1 over tangent, right? Cotangent is the same as 1 over tangent. Now, why is that any better?
Because we can type in 1 over tangent.
Right, you can type that in. So, what we have to do is rewrite this so we can type it in. So, let's take and let's fix this so we can type it in. So, Jake, how did you know cotangent was 1 over tangent? Did you just remember you flip it?
Yeah,
You just remember you flip it. All right. Well, if he takes and does that, that's fine. He took and he flipped it. But if you flip what's on the left, what else do you think you have to flip? You've got to flip what's on the right. me do it. All right, so let me try to explain it a little differently. We don't have a button for cotangent, all right? So right now we have no way to type that in. There's no button that says CO2. So the only way we can type it in is if we can rewrite it a different way. You know what? I'll do it a little different. I think it'll be even easier. If you take, let's just do it like this. Let's just flip each side, right? We're going to pretend that that's over 1 and that's over 1. We're going to flip what's on the left, and then we're going to flip what's on the right. If you flip what's on the left, you get 1 over cotangent. What's that the same as? That's tangent. All I did was I take what was on the left and I flipped it. It became 1 over cotangent. And if you flip the cotangent, that's the tangent. Now, if you flip what's on the left, you also have to flip, you got to flip what's on the right. You got to do the same thing on both sides. If you flip 2.5, you get that. So this is exactly the same problem you started with, except now you've written it with a function you have a button for on the calculator. All right, so now let's graph that. The reason I want to graph it first is because graphing will tell me what? When you graph it, what does the graph tell you? How many solutions, right? Am I looking for 1? Am I looking for 2? Or am I looking for more? All right, let's hope it's 1 or 2. Now, you can type in this, or you can type in step 2. They're the exact same problem. It does not matter which one you type in. I'm going to type it in this way because I have a button for it. Tangent x and 1 divided by 2.5. All right. Now, before I hit graph, I want to set my window so I'm only seeing 1 cycle. I don't want to see 2 or 3 or 4 cycles. What's the formula to find the length of the cycle for tangent? Yep. It's pi over b. What's b in this case? Just a 1. So the period for tangent is pi over 1, which is pi. That means I should set my window to be 3.14 units wide. And this is 1 cycle. How many times do the graphs cross in 1 cycle? Just once. Yeah. So this time, you only have to find 1 answer. Now, why does this graph look like that? It looks like it's not connected. Because it's tangent, and tangent has a what? It has a vertical asymptote right here. Okay? It has a vertical asymptote, and you only have to find 1 answer. So, how do I get rid of tangent and get x by itself? Take the inverse. Take the inverse tangent of what's on the left. Bless you. Take the inverse tangent of what's on the right. And now we do that out, and that's our answer. The inverse tangent of 1 over 2.5. So second inverse tangent. I'm going to calculate the intersect and make sure it matches, but it should be 0.381 if you round. And how often does that answer repeat? Every pi. Right? Every pi units. Right? So this one had a period of pi, so it's not 2 pi, it's 4 pi. Let's calculate the intersect and see if we get 0.381. So enter 0.381. So by taking the inverse tangent, we did get the correct answer. So now The next cycle will have an answer at 0.381 plus pi. Whatever 3.14 is plus 0.381, that's the next time that these two graphs cross. How about after that? Add another 3.14. After that, add another 3.14. Just keep adding 3.14 to that number, and that's where they cross every time. Any questions why you don't need the second answer here?
Hey, is there a second?
There is no second answer. Because we set our window to one cycle, I only see one answer on the screen. Now, if there was a second answer, and you were looking for where tangent is positive, besides quadrant 1, what other quadrant would you be looking for? 3. If you were looking for a positive tangent, you'd be looking for quadrant 3. And what's your formula if you're in quadrant 3?
180 plus reference.
It's 180 plus the answer that you got to start with. Or if you're not doing degrees, instead of 180, pi. If you were looking for an answer in quadrant 4, maybe you're doing a cosine problem, it would be 360 minus the answer you got. Or 2 pi minus the answer. Okay, so you never use all of these in the same problem. You only need one of them. It just depends which quadrant you need to be in. Not sure why this looks a little fuzzy. Does anyone else still need a coffee? You got, yep.
I just have a question.
Yeah.
For a cycle of cosine, what is that equal to?
So if you have sine, cosine, did I put it over here? Secant or cosecant, they all use the formula 2 pi over b.
Okay.
Sine, cosine, secant, cosecant. There's your formula. Tangent, cotangent, it's pi over b. So on your test this week, your reference sheet, I think there's a lot of good things you could already be putting on there. The idea of how to find the period, you might want to write what all this means. This is how to calculate the period. And the stuff we had on there before. This stuff. Okay, other questions on that? Okay. Okay, so the homework on, it's on 394. Tonight it's actually the same page as the last homework assignment, but that was like a month ago. So it's 37, 38, 41, 42, 45 through 47, and 49 through 53. Okay, so I think it's like 10 or 11 questions. We'll look at that tomorrow. And again, hopefully on Thursday we'll have enough time to do a review.